4 is not enough now to compensate for 7 and 8. But if you add another wealth recipient 5, you end up having enough to match the aggregate wealth of 7 and 8. Again, this tells us that Q of Z and 2 is equal to 5. And it also tells us, this tells us that R of Z and 2 is also 0, right? We don't have any violation of this inequality for all t, but we have a situation where the Q value for Z is higher than the Q value for Y. And again, without further information, without taking into account that this is actually dominance relation, we cannot contradict this. What we can do though is we can play around with these inequalities, particularly in this one. I'll call this condition 1, this is 2, this is 3. So we do something very simple. From inequality 2 is if we add y5 plus y6 on both sides, the inequality is preserved, obviously. So we get y1 plus y2 plus y3 plus y4 plus y5 plus y6 is greater than or equal to the sum of the top 4 levels of wealth, right? Simply adding the same stuff on both sides of the inequality. So this tells us that we now have, if we want to compensate for 4, so for the top 4 individuals, we need 6. So Q of the Y and 4 is 6. And now we do have an overlap. The size of the overlap, if we have to compensate for the top 4, is 2, right? From inequality 3, there it is. We get that because the bottom 4 were not enough to compensate for the top 2. If we add Z5 plus Z6 on both sides, the bottom 6 will not be enough to compensate for the top 4 either. That in turn tells us that the number in the distribution Z of low wealth people we need to compensate for the top 4 certainly exceeds 6, right? 6 are not enough. And it also tells us that R, the size of the overlap that we have in order to achieve this compensation, this matching, has to exceed 2. An overlap of 2 is not enough. So that means this has to be greater than 2. We combine these two, that means R of Z and 4 exceeds R of Y and 4, and that's a contradiction to 1. Again, this is just an illustration. In general, you have to make sure that it works for all possible cases, not only when the difference between the two is 1, that you can fill them up right away. You have to have a few additional auxiliary inequalities once in a while. But that simple argument is essentially the bottom line. So as a result, basically we have that these two really are completely, these are identical. The transvariation relation and the collegial concentration relation are identical. So in a way, one way of looking at that is if we go back to the original idea of transvariation, as I like to call it, cross-contamination. This is something that actually may have its applications in analyzing the concentration of influence. Now, as I mentioned, and as some of you already pointed out, this is still a very crude quasi algorithm, right? I mean, there's something that in a way, for my taste, there are not enough interactions. right? As I illustrated earlier, if you look at the situation where the group of wealthiest includes almost everybody, it seems not a very significant observation to look at how many really all of them or n minus 1 to compensate. What really matters is what happens near the top. So again, one way around this is to look at groups of people rather than just individuals. Another issue that sometimes people have raised is if you look at wealth distributions, it's not necessarily a good idea to exclude negative numbers because in essentially every society there are people who have net debts, right? That if you have a net debt, your wealth is negative. And we cannot very well accommodate that here, simply because if you allow wealth levels to be negative, there may be situations where there simply isn't enough if you add up these values to compensate for the top person. But to us, that's not an issue at all. And the reason why it is not an issue is that we interpret these wealth level as the amount people can spend on political campaigns. If you have a debt, if you don't have, not only do you not have money, but you have a debt, right? You have a negative wealth. The maximum amount you can contribute to a campaign or to a candidate is still zero, right? You cannot transfer a debt you cannot transfer negative wealth to a candidate or to a party. I mean, it would be great, right? I mean, if I would be hugely indebted, I'd gladly transfer my negative wealth to the Trump campaign. I mean, but I mean, it doesn't work that way, and in that sense, we're perfectly comfortable with sticking with this domain. Same thing, if nobody has anything in the economy, the whole question becomes moot, right? There is no concentration of wealth if there isn't any. So that part doesn't worry us in the least. Another remark I'd like to make is this quasi-ordering is actually an inequality quasi-ordering in the sense that it satisfies what we think of as the defining properties of an inequality measure or inequality quasi-ordering. It's minimal net equality. If you have an equal distribution, you get a situation where any equal distribution is associated with less concentration than any unequal distribution. That follows immediately because if you have an equal distribution, the number of low wealth people you need to compensate for the T top is T, right? Because they're all the same. And as soon as that's not true, if there is an inequality, clearly the lowest will be less than the highest. So to compensate for the highest, you need more than one. And that already gives you street ranking. By the same token, all equal distributions, no matter at which level, will be affiliated with the same level of concentration because there is none. That's the minimum possible value. So minimality and equality is certainly satisfied. Anonymity is satisfied. We worry about rank orders only, so any permutation is indifferent or equally concentrated than its origin. And clearly the Pigou-Dalton transfer principle in its weak form, with weak inequalities, is satisfied because you can transfer somebody from any possible amount from a high wealth person to a lower wealth person. It helps you to reduce concentration simply because this transfer works in favor in both directions, right? Any top level aggregate can only go down. Any low level aggregate can only go up as a consequence of this transfer. But sometimes with inequality, sometimes with strict inequality, so you're absolutely safe. And finally, this is actually a relative inequality quasi-ordering because if you multiply all the components of distribution by the same positive scalar, what you get is exactly the same inequalities that you had before. So this is indeed, this can work as an inequality quasi-ordering. In that case though, not being able to capture negative values is a bit of a shortcoming, right? Because if you want to measure inequality, it does